All right, now we're going to talk about matrix arithmetic. In particular, right now we're going to talk about how we perform addition and subtraction of matrices and vectors. So first thing we need to note is that if we have two matrices, okay, A and B, then they need to have the same shape, okay? So they both would be elements. We're talking about here the real numbers. They could be complex, but here we're talking in particular about real matrices. That's M by N. So this would be the set of all M by N matrices where the values are real numbers, okay? So if A and B are both that, then we can form A plus B. And how do we do that? Well, let's say A has this generic shape, A11, A12, dot, 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 A1N, right, because there's N columns. And the second row then would be A21, A22, dot, 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 A2N. Work our way down. Then we'll have row AM1, dot, 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 AMN. Right? So there's M rows, N columns. B also has that shape. So B11, B12, dot, 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 B1N, dot, 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 down to here, BM1, BMN. So when I add A to B, then these have, let's draw it this way. Let's say A has this shape and B has the same shape. Think about overlaying one of these on top of the other one and adding the corresponding numbers. So we talk about the number that's in this position of both, A11 and B11, we add those together. So this new matrix here, which will also have shape M by N, will have this first element, which is A11 plus B11. And to the right of that, we take the second number of the first row in each matrix. So excuse me, this would be A12 plus B12. And then dot, dot, dot over here. And then A1N to B1N. So A1N plus B1N. And the second row, we take the first number of the second row from each of these. So this is A21 plus B21. All right, then work our way across. And we continue down, taking each number on the first column here. Eventually get down to the bottom number here. So this is AM1 plus BM1. Do this for all these other numbers, and eventually get to the bottom right hand corner. This is AMN plus BMN. All right? So let's say we have this example. A is equal to 1, 2, 3, 4, 5, 6. Let's say that B is equal to 2, 0, minus 1, 0, 3, 4. So then A plus B will have what number here? 1 plus 2. To the right of that, 2 plus 0. To the right of that, 3 plus minus 1. So 3 plus minus 1. And then below that, 4 plus 0. 5 plus 3. 6 plus 4. And then if we simplify, we got 3 and 4 in the first column, 2 and 8 in the second column, and 3 minus 1 would be 2, 6 plus 4 is 10 in the third column, and this is A plus B. So it's really that simple. What about subtraction? Same basic idea, except now, if A minus B, that would be A11 minus B11, A12 minus B12, and so forth. And this would continue down. Okay? So using these two matrices, let's say we have A is equal to 1, 3, 0, 0, 4, 0. b is equal to 5, 6, 7, minus 1, minus 2, minus 3. So then a minus b will be equal to 1 minus 5 right here. 3 minus 6 right here. 0 minus 7 right here. And then 0 minus a minus 1. 4 minus a minus 2. 0 minus a minus 3. And this simplifies into 1 minus 5 is, minus 4. 3 minus 6 is minus 3. 0 minus 7 is minus 7. 0 minus minus 1 is positive 1. 4 minus a minus 2 is positive 6. 0 minus a minus 3 is positive 3. And there's our answer. So it's really that simple. So let's look at some properties of addition and subtraction. Now, I've taught linear algebra for many years at a university, and I find that some students pick up the rules of what's legal and not legal, and other students try to rely too heavily upon what they already know and don't make the adjustments. Now, some of the rules you learned about arithmetic of real numbers will also be true when we're talking about matrices and vectors, but some things won't. All right, and you just have to learn when they're the same and when they're not. So if we're talking about real numbers, we know that a plus b is equal to b plus a, right? So we say it's commutative. That is, addition is commutative. Okay? But a minus b does not equal b minus a in general. Right? 1 minus 2 is not the same thing as 2 minus 1. Then we also know that we have given a plus b plus c, that we need to either say add a and b together first and then add c to that, or add b to c first, then add a to that. Okay, this is associativity. So we say it's associative. That is addition. Okay? Well, matrices. Turns out each of these is the same. So a plus b, where these are matrices, is equal to b plus a. Why would that be the case? Well, think about what we saw before. If I'm adding a11 and b1 right here to produce part of a plus b, wasn't that the same as if I said b11 plus a11? Well, sure. Because addition of real numbers is commutative, then this right here leads to the entire matrix arithmetic, or addition, being commutative. All right? We also have that a minus b is not equal to b minus a in general, just like this is in general, for the same reasons. And then we know that a plus b plus c, if they're matrices, if we think about how that's produced, what would be the final result in the upper left-hand corner of this? What would be a11 plus b11 plus c11? So since we're adding those three numbers, the order in which we add them doesn't matter. So that means this can be performed as a plus b plus c, or b plus c plus a. Okay? So these particular rules are the same. Real number addition is commutative. Matrix addition is commutative. Real number subtraction is not commutative. Right? Order matters here. Same is true for matrices. Real number addition is associative. We have to pick two things to add and then they add the third thing to it. Same is true here. Okay? Before we leave, since I was talking about matrices, how does this relate to vectors? Well, it's the same. So in some sense, we can think about a vector, right? If we have, say, x, where it has elements x1, x2, xn, We can think of this, if it's a column here, as having shape n by 1. So if I want to add vectors, the same rules apply. So if I have, say, x is 1, 2, 3, and y is 4, 5, 6, then x plus y is a new vector where we have 1 plus 4 here, 2 plus 5 here, 3 plus 6 here, and this simplifies to 5, 7, 9. Subtraction works just like a different matrices. If I had x minus y, this would be 1 minus 4, 2 minus 5, 3 minus 6, which simplifies to minus 3, minus 3, minus 3. And then associativity would also apply. If I had a third vector and I want to add to these, I have to pick 2 to add, and then I add the third to that. Okay? So really you can think of vectors as being like n by 1 matrices in terms of these rules. They're the same whether it's a traditional matrix or it's a vector in this case.